Alright, welcome back guys. This video is going to be about the properties of water. So I kind of felt like the chemistry and the water were just too much for one day. And so this is going to be a little bit of a review of some of the chemistry concepts that we talked about yesterday. But we're just going to specifically focus on some of the many special properties that water has. And we know that water makes life possible. Our cells are majority water. They're giant solutions, and water is the main solvent. And so water can come in different states. We're familiar with, liquid water that we drink and swim in and bathe in. And you've got your ice water, which is the solid form. And then you have gas water vapor. And so water is very unique, and it's got some properties that a lot of other substances don't have that allow for life and allow for life processes. And we're going to take a look at some of those. And so one of the reasons water has a lot of the properties that it does is because it is a polar molecule. So going back to our lesson from yesterday, we know that in covalent bonds, the key word was sharing, but when we have covalent bonds that form molecules, that sharing is not always equal, and that's what leads to polar molecules. So in the case of water, the oxygen is highly electronegative, and what that does is it causes oxygen to kind of hog the electrons. So even though they're being shared, they're kind of hanging out closer to the oxygen than the hydrogens. And so that gives that oxygen a partially negative charge. So we're not talking ions, we haven't lost or gained electrons, so it just becomes kind of negative in that region of the molecule. And then on the other ends, because the electrons are being held closer to the oxygen, those hydrogens become kind of positive. And it's these polar molecules that will have hydrogen bonds that form between them. And so water molecules are going to stick to each other by hydrogen bonds, those weak chemical bonds between those weak charges. And it's these hydrogen bonds that are responsible for most of water's unique properties. When in doubt, if the question is about water properties, it's probably going to go back to the fact that hydrogen bonds hold those water molecules together, and the hydrogen bonds are between those weak charges because water is polar. And so it's going to give water its basic structure and many of its properties. And so two properties that we're going to look at is cohesion and adhesion. And essentially water is sticky. Okay, both of these have to do with the fact that water is sticky. And why is it sticky? Well, it goes back to hydrogen bonds. So we have cohesion, which is where water sticks to water, okay? This is where something sticks to itself. And so those water molecules are going to stick to other water molecules. This is what gives rise to surface tension. This is the reason that little bug can sit on top of the water, is because that surface tension that's created when water sticks to itself. This is also the reason you can overfill a cup. You can take that cup and it will kind of have a bubble of water, and you can keep adding water and it will actually go higher than the cup before it finally breaks. And so that's also that surface tension. If you were in freshman biology, you may remember the penny lab, and we tried to see how many drops of water we could put on a penny, and it was actually quite a lot, and it formed that bubble over the penny, and that was due to cohesion. And so water sticks to itself, but then water also sticks to other things, and that's what the property of adhesion is. Water sticks to other stuff. And so this is what leads to capillary action. It literally causes water to climb tubes. Also, you can see adhesion like when you use a graduated cylinder. You may remember that hopefully you were taught at some point how to properly read a measurement in a graduated cylinder, but you have to read what's called the bottom of the meniscus. And so a lot of times what will happen is when you have that glass or that plastic graduated cylinder, that water kind of sticks to the sides, and so it creates this little dip. And so when you read the graduated cylinder, you have to get eye level and you read the bottom of the meniscus. And so the reason that meniscus is even there is because water is sticking to the sides of the graduated cylinder. And so the combination of cohesion and adhesion are both really important because the climbing effect of capillary action, as well as the water sticking to water, both of those are going to be important in moving water in plants. And so like if you've ever put celery like in colored water, you can see that the water climbs up the little tubes. And that's actually going to be a combination of both cohesion and adhesion that allow that to happen. All right, another special property of water is that it has a high specific heat. And specific heat has to do with how quickly a substance changes temperature. When you have a high specific heat, that means it's going to change more gradually. It takes a lot of energy to increase the temperature of water, and a lot of energy has to be lost in order to lower the temperature of water. And so water is pretty moderate in terms of temperature change. And so this is going to be important because, you know, we are full of water, and we would not want every time you walk outside and there's a temperature change for the temperature of our bodies to be constantly changing. And so this high specific heat also leads to a high heat of vaporization. That's how we can cool down through evaporative cooling. Those hottest molecules are going to leave as a gas. This also is important on climates, and that anytime you have a climate that involves large bodies of water, it's going to be more moderate. It's going to change temperature more gradually. You know, if you live on a coast, you know, the water temperature in an area is not going to be the same as the air temp, because as the air temp warms, it takes a lot longer for that water to warm. And that's why when you go swimming like in early spring, the water's still pretty cold. And even in summer, after it's been hot for a long time, the water is still cooler than the air temp. Is because it takes a lot of energy to change the temperature of water. And so that's going to be important for homeostasis purposes. That's going to be important for organisms that live in water. We wouldn't want those temperatures changing very drastically over short periods of time. Another important property is that ice floats, and this is kind of different from other substances. Normally, solids are more dense and they will sink, but if you put ice in a glass of water, the ice floats to the top. And once again, this goes back to hydrogen bonds. So whenever those temperatures fall, as the water begins to freeze, the hydrogen bonds actually cause those water molecules to kind of be held apart, and it creates this lattice structure. So it actually makes the solids less dense in the case of water, and that's why the ice will float. Now that doesn't really affect us that much in our daily lives. We don't really care too much that the ice floats in our cup. But if you were an organism that lived in water, that does make the ice kind of sit on top and allows it to be still livable underneath. Another important property is that water is a great solvent. A lot of times we refer to it as the universal solvent. And so just a quick recap on solutions. When you have a solution, you have a solvent and you have solute. The solvent is what does the dissolving. The solute is what gets dissolved. And so water is really good at dissolving things, okay? Now, water is especially good at dissolving ionic compounds or salts, those compounds that are made from the transfer of electrons, things like salts. They easily break up and dissociate in water. Water is also good at dissolving other polar molecules. So like dissolves like. Polar dissolves polar, okay? The water molecules will surround other polar molecules and cause them to break down and dissolve. And so those things that easily dissolve in water, we call them hydrophilic. They're water loving. There are things that do not dissolve in water, and those are going to be the nonpolar compounds or things that are not ionic. They're going to be hydrophobic. And so that's the reason like fats repel water, is because fats are nonpolar. So hydrophilic will dissolve easily and hydrophobic will repel. And then the last thing we're going to cover is pH. So this isn't necessarily directly related to just water, but it does involve water, and that pure water on the pH scale is neutral. It is neither an acid nor a base. And so just to kind of understand a little bit about what the pH scale is and what it's measuring, it's actually measuring the concentration of hydrogen ions. And so the numbers represent hydrogen ion concentrations. And so we know that it ranges from 0 to 14, and 7 is going to be right here in the middle. Okay, that's going to be our pure water. And the reason pure water is neither an acid nor a base is because the hydrogen ions are going to be equal to the hydroxide ions. And so water, if we were to look at the formula, it's H2O, And if this were to break down into ionic form, this is what we would get. So notice you can still see the 2 hydrogens there and the oxygen. So it doesn't really dissociate into ions like that, but if it did, they would be equal. And so when we're talking about acids versus bases, it has to do with the concentration of these ions here. So acids have a lot of hydrogen ions, and they have less of the hydroxide ions. So the more of these you have, the more acidic it is going to be. And on the pH scale, acids are less than 7. I like to remember that A comes before B, and so notice your acids are the lower numbers, okay, and your bases are your higher numbers. So acids come before bases on the scale, all right? Now, bases actually accept hydrogen ions in a solution, and so what happens is they end up having a really high concentration of the hydroxide. Okay, so bases are going to give off hydroxide ions in a solution. So acids give off the hydrogen ions, bases give off the hydroxide ions. And so these are going to be greater than 7 on the pH scale. And as you're looking at the scale, the closer you are to neutral, the weaker that acid or base. The further away you get in either direction, whether it be lower numbers or higher numbers, the stronger that acid or base is. So like a 1 is a really strong acid, whereas a 6 is a weaker acid. And so just know that water is in the middle. Pure water is neutral. It's neither an acid or a base. Your acids come before. They're your lower numbers. The lower they are, the stronger they are. And bases are your bigger numbers. The higher they are, the more basic they are. Okay? And so as you're moving along the pH scale, it is important to know that those concentrations of those ions, each step on the periodic table is a 10-fold increase in those ions. So if you're looking at acids, if you move from a 3 to a 2 would have more of the hydrogen ions, because the stronger the acid, the more hydrogen ions there will be. But if you moved from a 3 to a 2, that would increase it by 10. So there's 10 times more of those ions in a 2 than there were a 3. If we were to go 2 steps from a 3 to a 1, it would be 10 times from 3 to a 2, and then another 10 times from 2 to a 1, and so that would be 100. So each step that you take on the periodic table is a 10-fold change. So if you move 3 steps, it would be 10 times 10 times 10, or 1,000 times difference. So just be sure you kind of understand what those numbers are representing. And that's going to be all for your properties of water. What you're about to do, because obviously this is not going to take the whole class, and so what you're about to do is you're going to kind of just test yourself a little bit. So you do have a study guide that you can work in, and I would encourage you to take a look at that. There's definitely some important vocabulary you need to know, like cohesion, adhesion, things of that nature. But what you're going to do now is you're going to test yourself on macromolecules. So our next lesson is going to be about these 4 macromolecules or biomolecules of life. And so I'm kind of curious, and hopefully you're kind of curious about what you know and what you don't know before we ever even go over it. And so just kind of for fun, you guys are going to get in some groups and you're going to go over and just kind of see what you know about carbs, lipids, proteins, and nucleic acids. So Ms. Petty's going to give you some instructions on that. In terms of quiz, you're not going to have a quiz until macromolecules have been covered. So we're going to do some notes on macromolecules. You have an activity that you're going to do a couple of days over macromolecules. And so the quiz on chemistry and water and macromolecules will all be at a later date. But it's going to just be one quiz over kind of both PowerPoints. So I hope you guys learned a little bit about water today, and I will be making another video soon. Have a good day.